Hello students, good morning, good evening and good night. Depending on which time you are going to observe this lecture. This lecture is in continuation of our previous lecture. In the lecture number 3, we have discussed about the different properties of the amines. That is, we have first discussed about the physical property, then we have discussed about the chemical properties. And in the chemical property, we have discussed some 5 very important reactions. That is, first we have discussed that is the basic property. Then we have discussed the acylation property, or you can say acetylation property. Then we have discussed about the reaction regarding the Schiff's base and carbyl amine reaction or isocyanide reactions. And we have discussed the reaction with the nitrous acid. So in this lecture we will continue with the 6th number of chemical reaction as being undergo by the amines. So heading of today's lecture is the properties of the amines, that is in the part 2. This is K.K. Mukherjee in the Science with Mukherjee Sir YouTube channel. So we are going to discuss the 6th number reactions. 6th number reaction is very important reaction because with this reaction we are able to identify the 1 degree amine, 2 degree amine or 3 degree amine. And we also able to, if there is a mixture of these 3 amines, if anywhere is there, then we can able to separate it from each other. And this reaction is very important reaction. It is called Hinsberg reaction. Hinsberg reaction. In this reaction, the reaction is undergo by the benzene sulfonyl chloride, which is also called the Hinsberg reagent, with the primary amines and secondary amine. But this reaction is not going to be taken by the 3 degree amine. You cannot observe this reaction for the 3 degree or tertiary amine. So let us see the reaction. This is benzene sulfonyl chloride, and we are observing, noting the reaction with the primary amines. So we have taken the ethyl amine and this is benzene sulfonyl chloride. So here what is going to happen? Hydrogen and chlorine. This is basically, you can see there is a elimination of the HCl formed with this reaction, and it is going to produce this. This is called N ethyl benzene sulfonamide. This product has been produced from this reaction, Hinsberg reactions. So here you can see there is one hydrogen atom left in this benzyl sulfonamide, and due to this fact that sulfonyl group, this is a sulfonyl group, is very much highly electron neutral, And we know if there is any species which is electron withdrawing and that is being placed in the compound, what is going to happen? It will create, if there is a hydrogen atom, it will create the hydrogen atom is very active, and this hydrogen atom can be easily released as a H plus ion. That is why this is highly acidic. So it can be easily dissolved in KOH. So this compound is easily dissolved in KOH. Okay. Now we will understand the reaction of this benzene sulfonic chloride with, we have taken this so this is the 2,2-diethyl amine, that is a second degree amine. So here also you can see there is a elimination of one molecule of HCl, and it is going to produce this is called N,N-diethyl benzene sulfonamide. And here you can observe one thing, the difference between these two compounds, that here there is one hydrogen atom but there is no hydrogen atom. So this compound is not acidic at all. So it is not dissolved in KOH or alkali, not dissolved in alkali, dissolved in alkali. So what is going to happen if there is a mixture of these two compounds, that is 1 degree, 2 degree. So if we use this reaction and this after the production of this will dissolve, but this will not going to dissolve. So we can able to separate it out. And another thing is that 3 degree amine, as because the 3 degree amine do not have any hydrogen, so it will not going to take part in this reaction. So we understand the Hinsberg reaction. It is basically the reaction with the benzene sulfonyl chloride with the 1 degree amine or 2 degree amine. But this reaction is not to be undertaken. This is not to be undergo by the 3 degree amine. So this is the 6th number reaction we have discussed. Now we will discuss the 7th number reaction, that is coordination compound. Coordination compound. This is a special type of compound that one chapter has been kept in your syllabus, that we will discuss later on about the coordination compound. How this compound is going to form, that we will discuss in detail, but here for the sake of this reaction, that because the amine also form this coordination compound, this complex compound like ammonia. So reaction of this, it will basically react with the cations, and this is the reaction we are showing, that AgCl with methylamine, AgCl with methylamine, and here you can see this complex compound has been formed. This is Ag with 2 molecules of CH3NH2 and it is plus, and there is another Cl minus. So what is going to happen? AgCl, when it is produced with the reaction of NaCl and NaCl and AgNO3, there will be the white precipitation we will observe. This will not dissolve in water, but if we use this methylamine, it is going to be dissolved. So why it is dissolved? Because there is a formation of the complex compound. So next reaction that is we are going to discuss, that is alkylation. Alkylation. This will not, already we have discussed when we are talking about the Hofmann aminolysis reactions. At the time we observed that 1 degree amine with the reaction with the alkyl halides, it will become 2 degree amine. 2 degree amine with the reaction with another molecule of alkyl halides, it is 3 degree amine, and ultimately that quaternary ammonium solid has been produced. This is basically the alkylation reaction. Next reaction that we are going to discuss, reaction number 9, that is the exhaustive methylation. Exhaustive methylation reaction. Exhaustive methylation reaction, what is that? Let us understand. It is basically with the excess methyl iodide. When the ethyl amine has been reacted, it is going to produce the quaternary ammonium salt. And this reaction is, you can see that we are taking C2H5 NH2, and we have taken the methyl iodide, and this is exhaustive methylation process, because they are using the methyl iodide. Exhaustive methylation, and it is going to produce this. That is N-ethyl trimethyl ammonium iodide. Ammonium iodide. So we understand this is a quaternary ammonium salt. Next we are going to discuss the 10 number reaction, that is the Hofmann elimination reaction. Elimination reaction. In this case, when we undergo pyrolysis of the quaternary ammonium hydroxide, at that time it is going to produce the least saturated alkenes. Normally when there is a dehydration, with the alcoholic dehydration we will say, that is the Sertsev reaction, at that time we find the formation of the alkene which is highly substituted. But here in the Hofmann elimination we will find this is least substituted. Now see this reaction. Reaction is this: we have to take this is quaternary ammonium salt. Here it is called, the name of this compound is secondary butyl trimethyl ammonium hydroxide. Ammonium hydroxide. And when we undergo the pyrolysis process, in this pyrolysis process, what we find that there is a production of this alkene, that is 1-butene, and also 5% we observe 2-butene. So 1-butene is 95% and 2-butene 5%. This is, you can see, this is the least substituted alkene. So this is Hofmann elimination reaction. That secondary butyl trimethyl ammonium hydroxide, when it is go undergo the pyrolysis, it is going to produce this alkene, which is least substituted. And 95% we find the 1-butene and 5% is butene. Okay. We are discussing the reaction of the amines, that is a part 2. We have already discussed different reactions, that is now we are going to reaction, very important reaction, that is reaction number 11, that is the electrophilic substitution reaction. Electrophilic substitution reaction of the aromatic amine substitution reaction. A electrophilic substitution reaction. Here aniline has been taken, for example. Aniline is the least, that is the, we can say that is the most simplest version of the aromatic amines. So aniline structure we know, that is this. This is the aniline, and the amino group is directly attached to the benzene ring, and this having nitrogen having the lone pair of electrons, and this lone pair electrons has been donated to this benzene ring, and thus it will very much activated towards the electrophilic substitution reactions. And as it is electron donating, and if you see the structure, resonating structures, during the resonance, there is a 5 structure we know. These 5 structures, let us understand this 5 structure. Number 1 structure is this. And this is going here, and at that time this electron lone pair, that is loose electron, goes here. What is the structure? Here this can come here, and here it is come here. Another resonating structure is this. So these are 1, 2, 3, 4, 5. 5 resonating structure you can see. And from this resonating structure, what we understand, that there is the electron is concentrated in the ortho position or in the para position, ortho position or in the para position. That is why when there is a electrophile attacking the benzene ring, it will naturally going to be attached in that position only. So it is the ortho and para directive, you can write ortho and para directive. Now some reactions we are going to understand. Number 1, that is the bromination. Bromination reaction. In this bromination reaction, as it is a very active compound, you can see with the room temperature this reaction is going to happen at the room temperature when the aniline is react with the bromine water. Just bromine plus water at room temperature, it is going to be create a precipitation, that is color is white. See, this is going to be produce this bromine 2,4,6 tribromoaniline. It is going to produce the 2,4,6 tribromoaniline. Tribromoaniline. Okay. And it is so reactive that you cannot able to stop the reaction at the mono-substituted state. And for that we have to protect this amino group. And for that we have to undergo the acetylation process first. And then we have to make the bromination. After that, hydrolysis will be able to produce the para-bromoaniline. So what is the reaction? Let us see. This is acetylation has been conducted in presence of acid anhydride and pyridine. We have to take pyridine as a base. So it will be acetylated. This NH group become NHUCH3. And at that time the activity of the amino group has been restricted. So it will not able to, this lone pair electron will be in the resonating with this oxygen atom, rather it will go to the benzene ring. It is less available to donate the benzene ring. So this is going to form, it is N-phenyl it is name of this N-phenyl ethanamide. Ethanamide. N-phenyl ethanamide. Okay. So after that we have to do the bromination with acetic acid, and it will produce the major product, that is para-bromo product. Para-bromo product it will produce this, and it is going to, then we have to hydrolysis is in either acidic or alkali. Then we produce this. We will produce the para-bromoaniline. Okay. So when we are going to produce the monosubstituted bromine compound in aniline, that we have to undergo this process. Okay. It is also going to undergo the nitration reaction. Nitration reaction. In the nitration reaction, what we find, there is a mixture of product. This reaction is this. H2SO4 and HNO3. Temperature we have kept 288 Kelvin. So here you can see there is a mixture of product. That is NH2, that is orthonitroaniline. It is almost 2%. Then we observe metanitroaniline. It is almost 47%. And also we observe this product, ammonia, and this is 52%, and this para-nitroaniline. So question arises, there is a big question arises sometime in the exam actually has been asked, that why there is a meta-nitroaniline? Why? What is the reason behind it? Because it is ortho and para direct. Because of this fact, at the high acidic concentration, this ammonia group has been transformed into aniline ion, and when there is a positive charge and it is become a highly electron withdrawing, and it is then this group is meta-directing group, and at that time you can see there is substantial amount of the meta-nitroaniline we have observed. Okay, now we will discuss the sulfonation reaction. We are discussing the sulfonation reaction. Sulfonation reaction. Sulfonation reaction. In the sulfonation reaction, we observe it will first produce this is aniline this is aniline hydrogen sulfate. Okay, this is aniline hydrogen sulfate. When it has been heated at 450 Kelvin to 480 Kelvin, at that time it is going to form this compound, that is this is sulfonalic acid. Sulfonalic acid. And this sulfonalic acid is in equilibrium with this. This is called deuter ion. This and SO3 minus. This hydrogen has been going to this amino group and it is become this, and this deuter ion, this is deuter ion. This deuter ion is very, very helpful to produce many sulfurides. Okay, next, that is the Friedel-Crafts reaction. Friedel-Crafts reaction. Friedel-Crafts reaction, whether the aniline going to show this Friedel-Crafts reaction or not, this is not going to show the Friedel-Crafts reaction, because of the fact in Friedel-Crafts reaction what we use, we use a Lewis acid, that is aluminum chloride. And this aluminum chloride going to make a salt. It will make a salt with the amino group, and it is going to produce this. And this when going to produce, it is as the nitrogen is positively charged, then it will a deactivating species. So it will not going to show the desired reactions. So that is all for today's lecture. In this lecture, that is a part 2 of the chemical property of the amines. We have discussed some very important reactions, that is the Hinsberg reaction. Then we have discussed about the electrophilic substitutions reactions and all those categories that we have discussed. Hope that is been clear to you. And if you like this video, you can share to your friends, and this is basically a service to the students who cannot afford the costly tuitions. Hope this will going to help them to clear their points, clear their doubts, enrich their knowledge, and help them achieve their targets. Thank you very much for watching, and we will see in the next lecture. Thank you.